Bismillahirrahmanirrahim. Welcome everybody. So let's start the fifth lecture of the chapter solids, and that is the structure of sodium chloride. Now listen this lecture very carefully because in this lecture we are also going to discuss how to draw the structure of the sodium chloride. Sodium chloride is an ionic solid which consists of sodium ions and chloride ions. The configuration of sodium ions is 2 8. Total are 10 electrons, out of which 2 are present in the K shell and 8 are present in the L shell. Chloride ion has configuration 2 8 8. Total are 18 electrons, out of which first shell has 2, second shell has 8 and third shell has 8 electrons. Now there are 2 shells in the sodium ion and chloride ion has 3 occupied shells. So the size of chloride ion will be obviously greater than that of sodium ion. The cationic radius of sodium ion is almost 102 picometer and that of chloride ion is 181 picometer. So chloride ion are bigger than the sodium ions. Now the structure of any ionic solid, especially its coordination number, it depends upon the radius ratio. And radius ratio is actually the radius of cation divided by radius of anion. So this one is the radius ratio which decides the structure of the ionic solid. Greater the radius ratio, it means larger will be the cation. And larger the cation and greater the radius ratio means greater will be the coordination number. So radius ratio is actually directly proportional to the coordination number. What is meant by the coordination number? We are going to discuss it in short duration of time. Now, in case of sodium chloride, what should be the radius ratio? That will be 102 picometer divided by 181 picometer, and it comes out to be 0.563. Now this one is the radius ratio of the sodium chloride, and this radius ratio shows that the coordination number of sodium chloride, that should be equal to 6. Coordination number means that how many oppositely charged ions surround a specific ion. Mean how many chloride ions surround a sodium ion and how many sodium ions surround a chloride ion. And 6 coordination number means that 6 sodium ions will surround 1 chloride ion and 1 chloride ion will be surrounded by the 6 sodium ions. So it means that coordination number will be 6. Now in case of cesium chloride, you know that cesium has greater radius as compared to the sodium. So the radius ratio of the cesium chloride will be greater. And because of the greater radius ratio in case of the cesium chloride, its coordination number is also greater, and that is almost 8. So each cesium ion is surrounded by 8 chloride ion, but one sodium ion is surrounded by 6 chloride ion. So coordination number of cesium is 8 and that of sodium is 6. Now let us now discuss how to draw the structure of NaCl. It's very simple, not a big deal. Draw 4 dots like this. Now again make 4 dots almost at an angle of 45 to this. Like this. So after making these dots, now join them. So you will get a cube like this. Now, these circles, these are actually the chloride ions which are present at the corner of the cube. So 8 corners, they have 8 chloride ions. Now you know that between these chloride ions there will should be sodium ions. So now between every 2 chloride ion make a sodium ion. After making these 4 sodium ions, now you are required to join them like this. Now this will be the center of this face, and you know that the ions which are present or which are shown at the corners, they are also present at the center of the faces. So also make chloride ion in the center of this face. This one is again a chloride ion present at the center of this face. Again, between these 2 chloride ions place a sodium ion. Again, between these 2 chloride ions, exact in the mid, place a sodium ion. And similarly here, again place a sodium ion. Now join these ions together. And again, you will get center of the face, place another sodium ion here. Sorry, chloride ion here. So these are the chloride ions shown with the black. Again, between these 2 chloride ions place a sodium ion. Between these 2 chloride ions again place a sodium ion. And now join them. Like this. So these 2 chloride ions make a sodium. Between these 2 chloride ions again make a sodium, and between these 2 chloride ions make a sodium ion. Now join them together. Again you can see that there will be center of the face. So again place a chloride ion here. Now there are 2 sodium ions that are still you will have to join them. Like join this one and this one together. Now look at this carefully, that again 2 centers are created. One is this one, center of the back face, and one is this one, center of the front face. Again place 2 chloride ion here. So chloride ions will be at the center of the faces and they will be present at the corners. And the sodium ions, they are present at the center of the edges. Now at the end you are required to join all chloride ions present at the center of faces together. Join these 2 chloride ions. Similarly, join these 2 chloride ions. And to mention the center of this face, first of all join these 2 sodium ions and then place a chloride ion here at the center of the face. Now again join these 2 chloride ions together. So this one will make the structure of the sodium chloride. Now place a sodium ion at the center of all these. So sir, this one is the structure of the sodium chloride. Chloride ion are present at the corners and they are present at the center of the faces. So let us mention this one is chloride. So you will see total of the 14 chloride ions. While the ions which are shown with this blue, they are actually the sodium ions. So this one is the sodium ion. And total there will be 13 sodium ions. 12 at the center of the edges and 1 between the chlorides and in the center. So these are the sodium ions actually. Now let us look at the coordination number of this sodium ion. Focus on this please. Now this sodium ion is attracted or it is attached to how many chloride ions? 2, 4 and 2, 6. So coordination number of this sodium ion is 6 because this sodium ion is being surrounded by the 6 chloride ions. Now this is how to draw the structure of the NaCl. But a very important point now starts here, that how many formula units of sodium chloride are there in one unit cell or in one cube. How many formula units will be there? In order to calculate the formula units, we will have to calculate the chloride ions and sodium ions per unit cell. So first of all, let us calculate the chloride ions. Now chloride ions are occupying two positions, corners and center of faces. A cube has how many corners? 8. And how many faces? 6. So a cube has total 8 corners and 6 faces. Now every chloride ion which is present at the corner, when we draw it in the three-dimensional fashion, every chloride ion is surrounded by, every chloride ion is shared between the 8 cubes. Mean one corner is always of a cube is shared between the 8 cubes. So this chloride ion will be 1 by 8. Similarly, it will be 1 by 8. 1 by 8. All chloride ion present at the corners will be, one chloride ion will be divided between 8 cubes. So they will be 1 by 8. Now, it means that one chloride ion is 1 by 8 in one unit cell and total are 8 corners. So there are two ways. Either you will have to add 1 by 8, 8 times 1, 2, 3, 4, 5, 6, 7 and 8. Either add 1 by 8, 8 times, 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8, 8 times. Or you simply multiply this 8 with 1 by 8. So answer will be 1. It means one unit cell gets one chloride ion when in a crystal lattice. Now the chloride ion are also present at the center of the faces. So every chloride ion which is present at the center of face is shared between the two cubes. Just like consider the room in which you are sitting. Every wall can be shared between the two rooms if a room has an adjacent room with it. If this one is the wall of the room, then if there is a room backside to this, this wall will be shared between the two rooms. So every chloride ion is shared between the two cubes. It is 1 by 2. Similarly, it is 1 by 2. This chloride ion 1 by 2. This is also 1 by 2. This is present at the center of face 1 by 2, and this one also present at the center of face 1 by 2. So there are two ways. Either add 1 by 2 6 times, 1 by 2 plus 1 by 2 plus 1 by 2, because there are total 6 chloride ion present at the faces, center of the faces, are simply multiplied with half, and answer will be 3. So how many chloride ions are total per unit cell? 1 at with respect to corners and 3 with respect to center of the faces. So there will be total of the 4 chloride ions per unit cell. Now let us calculate the sodium ions. How many sodium ions are present per unit cell? You know that the location of the sodium ions is center of cube. At the center of cube, this sodium, it is only one sodium here. So there is one sodium at the center of the cube. And secondly, look at this sodium and this one. They are present at the center of the edges. So second location is the center of edges. Now how many edges a cube has? A cube has total 12 edges. Multiplied by. Now the sodium which is present at one edge, center of the edge, it is shared between how many cubes? One sodium is shared between 4 cubes. So every sodium write 1 by 4 with it. When you will write 1 by 4 with every sodium ion, it will be written 12 times. So there are two ways. Either add 1 by 4 12 times or simply multiply it with 1 by 4. Answer will be 3. So how many sodium ions there will be in one unit cell? 1 at the center of the cube and 3 with respect to center of the edges. So total sodium ions per unit cell, they are also 4. How many total chloride ions? 4. How many sodium ions? 4. It means total number of ions, listen very carefully, total number of ions per unit cell, that will be 8. And total pair of ions per unit cell, that will be 4. Now you know one sodium and one chloride. One sodium and one chloride. It is actually one formula unit of the NaCl. And if there will be 4 sodium ions and 4 chloride ions per unit cell, then how many formula units will be there? 1 sodium, 1 chloride, 1 formula unit, 4 sodium and 4 chloride. It means 4 formula units. So there will be 4 formula units per unit cell in the NaCl. And the shape of NaCl is face-centered cubic, because the ions which are present at the corners, they are also present at the center of the faces. So it is a face-centered cube actually. Now the last but not the least, a very important point. If we have 1 mole of NaCl, this is a very commonly asked MCQ. 1 mole of NaCl, or you may say 58.5 grams of NaCl. How many formula units will be there in 1 mole of NaCl? So 1 mole of NaCl, obviously it will be having Avogadro's number of formula units. But how many unit cells are there in 1 mole of NaCl? You know that 4 formula units, Fu means formula unit, that makes 1 unit cell. So 1 formula unit, 1 by 4 unit cells. And we have Avogadro's number. So Avogadro's number of formula units, 1 by 4 multiplied by Avogadro's number. It will be 1.5 into 10 raised to power 23, or you can simply write it as Avogadro's number divided by 4. So 1 mole of NaCl has Avogadro's number of formula units, but 1 mole of NaCl does not have Avogadro's number of unit cells. Whenever you are solving MCQ, please read carefully whether 1 mole of NaCl in the question it is asked it has how many formula units or how many unit cells. If there are formula units, simply Avogadro's number. But if there are unit cells, they are Na divided by 4. This was all about the structure of the NaCl. I hope so this lecture will be quite useful to you. Next time, inshallah, we will come up with some new lecture. Till then, Allah Hafiz.